This is the solution to problem 6 from worksheet 5.1, day 3, modeling exponential growth and decay. So I'm going to do the two half-life problems here, actually examples 6 and 7. So in example 6, we're told that strontium has a half-life of 25 years. So remember, the half-life is the amount it takes for the initial amount to decay to half of what it was. So in this problem, we're told that the initial amount is 30 grams. So just like any other exponential growth or decay problem, we're going to start with y equals a times b to the x. Here, we know that initially we have 30 grams. So one of our points is 0, 30. So at 0 years, we have 30 grams. Or we can just say that our a value, our initial value, is 30. So we have y equals 30 times b to the x. Now we need to determine b. In order to do that, we need a second point. And for that, we're going to use the idea of a half-life. So if the half-life is 25 years, that means when the time is 25, we'll have half of what we started with. So we will have 15 grams after 25 years. And we're going to use this second point to determine the value for b. So I'm going to substitute in 25 for x and 15 for y. So we're going to have 15 is equal to 30 times b to the 25th. And now we're going to solve for b. So we'll divide both sides by 30. And then we'll get 1/2 equals b to the 25th. In order to determine b, we can take the 25th root of both sides. So b is equal to the 25th root of 1/2. And if we get a decimal approximation, that's 0.97265 ... So our model is y is equal to 30 times 0.97265 to the x or t. So that's our model. And then the part B says how much will be left in 30 years. So in 30 years, x is 30. So we're going to substitute 30 in here into our model. So we're going to have y is equal to 30 times 0.97265 to the 30th. And I would keep this value for b in my calculator and just copy and paste that down from the previous calculation. And when you do that, if you enter that in your calculator, you'll get 13.06 grams is left. And that makes sense because we're a little bit more than one half-life. So we should have a little bit less than half of the initial amount. So after 25 years, we have 15 grams. So after 30 years, 13.06 grams seems about right. Now I'm going to go ahead and do the solution for number 7. So number 7 says the half-life of radioactive radium is 1,620 years. So this is going to be important. What percent will remain after 150 years? So for this problem, we are not given the initial value. So we can choose whatever value we like for the initial value. So let's choose something convenient. So I'm going to write that down, not given initial value. So we can choose a convenient initial value since we're only interested in the percentage. So you can choose a equals 100 or you might choose a equal 1. For this problem, I'll do a equals 100, right? Because we're only interested in the percent. So just like before, we're going to start with our model, y equals a times b to the x. I'm going to let a be 100. So y equals a times 100 times b to the x. Now we need a point to help us determine what b is. So the half-life is going to give us that point. So after 1,620 years, we have half of what we started with. So if a is 100, after 1,620 years, we're going to have 50 units left. So now I'm going to use that point to determine the value for b. So I'm going to substitute in 1620 for x and 50 for y. So I'm going to have 50 is equal to 100 times b to the 1620th. And I'm going to isolate b, so I'll divide both sides by 100. So I'll get 1/2 is equal to b to the 1620th. And then in order to isolate b, I'm going to take the 1620th root of both sides. And if I enter that in my calculator, I'm going to get b is equal to approximately, here you're going to keep a lot of decimal places. So 0.99957 ... And I'm going to write my model. So y is equal to 100 times b. So 0.99957, I'm putting ... because I'm going to put that value into my calculator. I'm actually going to copy and paste that from my calculator, because to answer this question, we want to know how much is left after 150 years. So after 150 years, I want to know the percentage that's left. So after 150 years, I'm going to let x be 150. So I'm going to say y is equal to 100 times 0.99957 ... copying that from down into our calculator to the 150th. And this is going to give us 93.8%. Where you're going to get 93.8. But we know that's the percentage because we started with 100. So there will be 93.8% after 150 years.